Oh, it did. It worked right off the bat. All right, shut up! Rumor was his homework assignment was too easy. All right, so remember at the end of last class, we'll talk about the assignment today. But I figured since it was so trivial, everybody got the right answer.
Yeah.
All right, so one of the goals here, and if you remember back from the first week of class, I kind of mentioned that the reason that programming is hard to learn. Are we all starting to feel that?
Yeah.
So first several weeks of the class when you're just doing book reading and stuff like that, thing is like, oh, this isn't so bad, this isn't so bad. Now we're writing some code, and it's like, this is really fun and easy, right? Okay, but remember I told you it was going to be that way, right? I said you're going to feel like you sucked at it, and every little assignment I'm going to give you something that's actually a lot harder than the previous one, but it's going to feel kind of just as hard. And then you're eventually going to get better and better and better, where if you look back to near the beginning of the semester, you'll see a problem that you remember spending 6 hours on that you could now solve in 20 seconds. Something like that. That will happen as long as you keep putting in the reps now. Well, remember I told you we had the discussion about why human beings have trouble becoming programmers. And what was the rationale for that? Why do human beings have trouble becoming good programmers? Should be in the notes somewhere. Go ahead. Well, computers aren't smart at all, so that's not really even saying much. Yeah.
So good at problem solving that they don't think about it.
Yeah, we are too good at problem solving. We can't break the problems down to those small little steps because we're not used to doing it, right? So I think something in the slides is probably somewhere along the lines of human beings are so good at problem solving that we have trouble articulating how we solve a problem. Does that make sense? Now, I promise you that is what has been challenging with these last couple of assignments. You know that if you had to solve it on paper, you could do it. When you see the solution in code, it makes sense. But it's taking those steps between the two that's problematic. Why? Because you have trouble articulating all the little tiny steps that are required to go from how you know how to solve it as a person to how to tell the computer how to solve it one tiny little step at a time. Okay, are we all kind of feeling that? That's where our challenge is right now. I mean, Python syntax isn't that big a deal. You're forgetting a semicolon here and there, or a colon at the end of a for loop or something here and there. You're forgetting a comma. I had an interesting bug yesterday. That took me 20 minutes to find. I'm sitting there looking at it. He sent me this bug, and it was one little missing comma up there in a place you just glance over, never even assume that's where it was. And so it's stupid little things like that. That's where Python's going to bother you right now, right? So you'll learn from that. Once you recognize that you kind of have a tendency of making some of those issues, forgetting to indent. That's going to be a common one with Python. You'll recognize that the real challenge is breaking things down into those small steps. Okay, so we're going to actually spend quite a bit of today looking at the solution to this homework from the perspective of breaking it down into small steps. Okay, and I think what you're going to find, I'm fairly confident you're going to find that we're going to probably break it down into smaller individual little steps than any of you individually did. Okay, at least that's my prediction. All right, so the homework assignment was to convert from any base to decimal. That's effectively what it is, right? I gave you the base 37, but any base that can be represented by the English alphabet is what I'm really saying. Okay, so convert from any base to decimal. Now, we've already come up with an algorithm for converting bases that don't have letters in them to decimal, right? So we already kind of broken down those steps. And not that, I'm sure many of you probably couldn't just sit down and write that immediately right now, but you'd be better at it right now than you were a week ago, right? Because you kind of gone through it, you've seen the pattern, you're like, oh, okay, I kind of get what I have to do now. You're putting in the reps, right? If you're a basketball player or a golfer or a soccer player or something like that, you can't just watch somebody on TV do something amazing in that sport and then just go home and do it, right? So you got to put in those reps and get the practice in until you're going to personally get better at it, but you should be better now than you were a week ago, even if it's just a little bit better, right? So what was the real challenge on this homework assignment? So this is kind of breaking it down into little steps. What was the one part of this problem that was probably the toughest? Go ahead.
I guess as like people, we see an A, we were told that that's going to be a 10, but if a computer sees an A, it's going to be an A. Just figuring out.
Okay.
And that's not.
So convert from values like A to a 10, etc. Right? So if we made that a little bit more generic, we might say mapping from the character representation of a, I'll just say digit, since we're all comfortable with that, even though for each different base it actually has a different name. For binary, it's bits. For octal, it's octets. For hexadecimal, it's hextets. And then for some of the other ones, I'm sure there's mathy made-up names, but they're digits, individual things in our string, okay? Mapping from a character representation of a digit to a number, right? That was a challenging part of this assignment. All right, so first thing that I would do if I'm solving this problem is I would pretend like the homework assignment is write the code necessary to map from a character representation of a digit to a number. We're not converting bases to decimal. We're not doing any of this other stuff. We're just solving that one problem. Now, at the end of last class, we talked about functions, right? What are functions? Reusable chunks of code. You write it once, and then you can use it over and over again. So if you ran out to Home Depot and you bought a little widget that you could drop any character into the top of, and it spit out the numeric equivalent of that, that would be helpful for this assignment, wouldn't it? So first part of the assignment is build that widget. Write a function that takes in a char, a character representation of a number. So maybe it's the character 0, the character 1, the character 7, the character A, the character F, and it spits out the appropriate number. If you pass it a 7, it'll spit out a numeric 7. If you pass it an A, it'll spit out a numeric 10. So what I'm saying here is if the input was a 1, it would spit out a 1. If the input was a 7, it would spit out a 7. If the input was a B, it would spit out an 11. That's the widget we are looking for. That's the tool that will help us solve this problem significantly easier. Does that make sense? Don't try to solve the big problem. Identify your sticking point and say, I just want to solve that problem. All right? So we want to write some code that will map from a character input. So that is 0 through 9, A through Z. That's what we're going to call our legal character inputs, right? And we want to turn that into the numeric equivalent. Okay? Now, we can be crazy about this. Now, remember, way back several weeks ago, whatever it was, I said it's significantly better to have an inefficient correct solution than an efficient incorrect solution, right? Don't try to overcomplicate your solutions at first. Write the crappy one that makes sense to you, and then see if you can figure out how to do it a little bit better. Now, we're not going to write the whole crappy one, but we'll start writing the crappy one so that you can kind of see like, oh, well, technically that would have worked. All right, so we're going to come into our code here. This guy get closed down. Ooh. So I've been storing on my desktop, right? Okay. So here's my code. Now, just to keep things simple and give us some practice, we're just going to dump that. We'll rewrite it again. No problem, right? All right. So that's also going to be helpful. Keep it somewhere in case you need to reference it. But the more times you have to train your brain to do these things, the better off you'll be. All right. But at first, we just want to write the code that converts from a character representation to the numeric equivalent. And we're going to do this as a function. So I'm going to define we're going to call this guy char to int. That's the name of the widget. Went into Best Buy, or Best Buy might have it, I suppose. But Home Depot probably. That's where we've been doing most of our shopping. So char to int. This guy's going to take in a char representation of number as a parameter. All right, and we want to map that guy to the integer equivalent, all right, and return that value. So we can be real explicit here. So this would be the long-winded, but hey, it'll work. Ask a zillion questions. If it's the character 0, return a 0. If it's the character 1, return a 1. If it's the character A, return a 10. We could do that, right? You can write 36 if statements. No big deal. Okay, a lot of copying and pasting. Not the way you probably should solve it, but you might say something like, if char rep of number is equivalent to the char 0, then we will return a 0. Else if char rep of number is equal to a 1, then return a 1. Else if blah, 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 blah. I'll throw the A1 in there just for our sake of testing it. So there's our A. We'll return a 10. So on and so forth, right? We can ask 36 questions. No harm, no foul. Some copying and pasting. Would that work?
Yes.
Okay, that's the 99-cent tool at Home Depot. And sometimes you'll build you'll buy the 99-cent one rather than the super expensive one that has radar and time travel and all that other stuff on it, right? Because this will work. Computers are fast. Who cares? Ask a zillion questions. Now, we're going to say this is probably not a very good solution for a computer programmer, but it's an accurate solution, and we are leveraging the speed of our computer to ask all these questions really quickly. We're not going to notice the difference speed-wise between this horrible accurate solution and what we might call the best solution. We won't notice a difference. Make sense? All right, so everybody kind of get what I was going for with this one?
Yeah.
This is fine. Nothing wrong with this, okay? In fact, if we wrote our code in terms of this guy, so let's just pretend like this guy right here is done, because we already had this program, didn't we? The only problem we had between what we wrote last week, or what we wrote on Monday rather, and now was the mapping from A to Z. Wasn't it? So if we have our function def base to decimal, and this guy takes in a value, we'll call it a value string, so whatever your string is as a your value representation, and then a base, or if you're a mathy person, call it a radix. Okay, but we're calling it bases. All right. What you're going to do is you're going to keep track of a couple of pieces of information, right? We're going to place always starts off at 1 because we have base to the 0th power is always a 1. We have our sum starts off at 0 because that's what we're summing up, right? We want to go through every single element of value string from the end towards the beginning. So that's our stock reverse for loop for I in range of length of value string -1 all the way up to, but not including bucket -1, step by -1. So that's that loop, right? That'll walk from the end of our string. Well, that really takes I on a voyage from the end of our string to the beginning of our string, and then we're going to use I to grab individual chars from this guy. All right, and then each time through, we're going to say sum is equal to sum plus place times char to int of value string at bucket I. So if this little widget we made does what it advertises as, if I toss it the character 1, it'll spit back the number 1. If I tossed it the character A, it would spit back the number 10, so on and so forth. That's what this guy is supposed to do, right? We didn't finish writing it because it would have been a zillion if statements, but that's what that tool is supposed to do for us, right? So when I write base to decimal, I am writing it in terms of this nice little tool here, where I'm saying, here is a character, I want you to give me the numeric equivalent of that. Up to this point, so last class we had int there, right? Which is a built-in tool that came with Python. And that guy will take a character equivalent of well, actually, I'll take a string equivalent of any number and give you the integer equivalent. But it only works for digits 0 to 9. Numbers containing digits 0 to 9. So you start throwing at things like A and things like that, it's a no-go. That makes sense? So that tool was not good enough for us to use for our homework assignment. So we went and bought a new tool. Char to int. Make sense? This guy does everything that old tool does, but then a little bit more. It works for those A's and B's and C's. Make sense? Go ahead.
Will you get an error message if you use that? I don't know why you would, but if you use that with just a normal number, you know, like where you would normally just use the int feature? Yeah.
Well, if I pass it the char 0 here, what does this guy return?
0. Okay.
Works for the normal number. Now, our little widget here that we're building, at least the way we're building it right now, will not work if I pass it like the string 123. Like the number 123, I want to convert that. Int can do that. Our current thing can't. But that's an excellent idea for a homework assignment. Yeah, great idea. I love that. So, remind me before class is over. So char to int is a widget that we are writing here. And this guy will take in a single character, 0 to 9, A through Z, and spit back the numeric equivalent of that guy. It's our own little special version of int that actually solves the problem for our homework assignment, right? So we'll increment our sum. Then we'll say place is equal to place times base. Ultimately, we will return sum. So that's our base to decimal written in terms of our new magical tool. Make sense? How many of you tried to write a whole bunch of weird crap inside of here? Many of you, right? Where really our problem was we need a tool that can just convert a char to an int. Let's make that tool. And you can make the crappy version of that tool that works. We'll just let the computer ask 36 questions, no problem. If it's a 0, here's a 0. If it's a 1, here's a 1. If it's an A, here's a 10. If it's a B, here's an 11. If it's a Z, here's a 36. Base 37, 0 to 36 are the allowable values. Make sense? So we could do the crazy if statement solution. It'll work just fine. No problem. But there's probably a solution that we can leverage our programming expertise to get a little bit better solution from this, right? So I'm going to write a string here. I'm going to call this guy map, and this is going to be I get it all? Is it possible to even write the alphabet without singing the little song? It's not possible, is it? Even when I was going back and checking, I was saying A, B, C. And how can we do LMNOP so quickly? Like,
It's a really tough question.
see, all these things are significantly harder than learning how to program.
All right. Now, what we heard the computer is how to solve the problem of putting sound into have the computer sing ABC.
Yeah. Well, our learning system has changed as well. How many of you know the whole Greek alphabet? Could like say the whole Greek alphabet? I don't know what most of the symbols are, but I can say the whole Greek alphabet. I've been able to say it for just years and years and years. And when I was somewhere in elementary school, I don't remember what grade it was, we had like an in-class competition of who could say the Greek alphabet the quickest on a burning match. Okay, so you got like fourth graders holding a match. Okay. Like alpha, beta, gamma, delta, epsilon, zeta, theta, capital M, the moon, Z, omicron, pi, rho, sigma, tau, epsilon, pi, chi, psi, omega. Over and over and over and over again until you got burned. Literally. They wouldn't allow that anymore, would they?
They better.
Man, that's when education worked. You learn this, kid, your hand's on fire. Because you're not allowed to drop that match until you've gone through the alphabet at least once. You know, I won too. I can't do it as fast anymore, but I could just fly through that on a burning match. Remember walking around the house practicing. I would do little stupid laps around the living room, saying as fast as I could for no good reason. I don't know why I was doing laps, but that's what I did. Man. What was I talking about? Oh yeah, burning matches. All right, so I have all of the legal quote digits in my possible numbers I might convert, correct? Okay, I have all those dudes. Now, this is a string, correct? Now, what is the first legal position in this string? What bucket is the first legal position in this string? Bucket 0. What bucket is the last legal position in this string?
Bucket 9. Bucket 10.
Give it to me generically first. That's not even generic. It should come out to a number. It's the length of map minus 1. That's what this bucket is. Right? Length of map minus 1. Now this guy has 36 characters in it. It should be 36? 26 in the alphabet, right? 26 plus 10, so that is 36 total characters. So legal buckets are 0 to 35. Yeah, so actually the biggest numeric representation we could do is actually base 36, not base 37. All right. So a 0 is at position 0. A 1 is at position what? 1. A 2 is at position what? 2. 3, 4, 5, 6, 7, 8, 9. What position is an A in?
10.
What position is a B in?
11.
These kind of map up real nice, don't they?
Excellent.
Yeah, these look good. So if I could search through this string and find the position in that string where a number existed, or where a char existed, could I just return that position? If I searched through the string and said, tell me what position a 0 is in. I found it right there at bucket 0, the numeric value 0. I found a 1 at numeric bucket 1. I found an A at numeric bucket 10, so on and so forth. Does that make sense? So I could write char to int like this. I can say for I in range 0 to the length of map. Okay, so this will take I on a voyage from bucket 0, 1, 2, 3, 4, blah, 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 all the way up to, but not including 36. So our last legal bucket is 35. I want to keep reinforcing that because the second value here says up to, but not including. This is non-inclusive. Okay? There's nothing sciencey about that. That is just how the range function works. Our range function says we start here, we go to here, but not including that value. Make sense? That's what Home Depot's selling these days. Okay, this is not a computer science concept. That's just how this tool works. And this one is inclusive. So it starts off with 0, including 0, goes all the way up to, but not including the length of map. And if I don't put a value here, the step value, what's the assumed step value? 1. We take single size steps. Just to go from a 0 to a 1 to a 2 to a 3, so on and so forth. So that's why I did not put a step there. But if it makes you happy, you can put a step there. All right? Or you can do what he did on his assignment and forget that comma. And you look past this over and over and over and over and over again, wondering why your loop isn't looping. Because you had one little comma missing. So just kind of giving you a warning, because that was a mistake he made, and I've been programming for a couple of minutes. And I was doing it during Bible study. Thanks for that, by the way. But I'm like, this code looks fine. It turned out to be the comma. But just throwing that out there is something to look for. If you're getting a weird output and everything else looks fine, go and look for little things like that. All right? So we're going to go through every bucket of map here. Bucket 0 to bucket 1, 2, 3, 4, blah, 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 blah. Each time through, we're going to ask a question. If the character I'm looking for is equivalent to the character I am looking at, return the position. If I was looking for a 0, the very first time through this loop, I'm going to find the character 0 at position 0, so I will return that number 0. I will be the number 0, then the number 1, then the number 2, then the number 10 and 11 and 12. So when I'm looking for an A and I find an A, I'll return where that A lived in that string. Go ahead.
For the length being the end, if it's non-inclusive, then could the I not be in Z since that's in bucket 36?
Well, this is bucket 0 to bucket 35.
Okay.
Yeah, because strings are indexed from bucket 0.
Okay.
So Z is included this time, but if I said that, it would not be.
Okay.
Yeah, that comes up 1 short. All right, so, and that's, the lesson from that question is that the length of a string is the total number of characters that are in a string. Then we have to remember that strings are indexed starting at bucket 0. So it's 0 to the length of the string minus 1 are the legal buckets in a string. All right, so our range function is kind of like built for that, pretty convenient for that guy. But it's a good question because you always want to make sure you're hitting all your search areas, right? All right, so in this case, we'll go through every possible place where we might find it, and we're making the assumption that you passed us a char that's in there somewhere, that you didn't throw us a question mark or something like that, right? Because we don't have question marks in here. So we're assuming that you're giving us a char that we will find somewhere in this string. We're going to go through every bucket of that string. Each time through, we'll ask a question. Is the character I'm currently looking at in my string the same character? So double equal sign says, is it equivalent to the character I'm searching for? If it is, I'm going to return the position in the string where that guy lives. Go ahead.
You have I twice in the code. Does that matter? Or it doesn't matter because they're two different functions?
Oh, you mean down here and up here? It doesn't matter. That deals with something called scoping rules. And I think I maybe have said this before, but let's throw it in the slides now. I probably won't go too far into it this exact moment. But I'm going to call this scoping rules. All variables resolve to their most local definition. Have we said that before? Something along those lines? All right, so when I have a variable like I here, I resolves to its most local definition. The most local definition of I relative to this guy is where I defined it right there. The most local representation of I relative to this guy is where it was defined right there. This function right here has his own scope, has his own like local environment where he could have his own variables, and those guys don't impact the variables that are in this guy's local environment. All right, that's kind of what scoping says. Now, on the flip side though, if I say I is equal to 7 up here globally, this variable I is actually accessible inside here and inside here. That makes sense? So in this case, this local I is set to shadow this global one because variables resolve to their most local definition. So this I right here will boil down to his most local version of I. This I down here will boil down to his most local version of I. And if after these functions here I print out I, so I'm not in either of those functions, the most local value of I relative to this guy is this one right here. Make sense? We'll have plenty of practice dealing with scopes and stuff, but that's like the quick answer here, so don't worry about that too much this exact moment. Okay, so char to int, I pass it any char. I just happen to create a string that just works perfectly for mapping characters to its numeric equivalent, right? I search through that dude. As soon as I find a match, I return where I found the match. So now my base to decimal, I'm using this brand new tool I just wrote. Pass in any char. That's one of the legal characters in our language for up to base, in this case, base 36 numbers. And I do all my math, and then ultimately my base to decimal is done. So I can say answer is equal to base to decimal. And if I want to put in BAD, and I want to say base 16, and I say print answer, I think this is 2989 is the, what that guy is. Oh, I'm on a, there's my 2989. It's because I converted this in my head real quick. It's my favorite hex number. Okay, but you know, put a whole bunch of numbers in there.
And be careful not to make sure. Well, I mean.
And then you want to put some more letters in there, whatever. Well,
no,
yeah. So now you just want to be safe. Just say this. I want this in base 36. And there's the decimal equivalent of that. That make sense? Does this code here make sense? That might have been, how many of you wrote code that's similar to this? I kind of gave you a hint last class. Remember that? Okay. Now, how many, did any of you write the monster if statements? Why not? Why didn't you write the monster if statements?
Because I didn't think that was a solution.
I figured there was a better way.
Well, definitely is a better way. But you didn't want to write 36 if statements even with copy and paste?
No.
You a coward? Are you like against right answers?
What?
Go ahead.
Does writing a dictionary defining the terms count as that?
Well, yeah. I mean, you could do a dictionary. It might be a little bit. Has the book talked about the dictionaries already? Okay. Yeah, you could do a dictionary. I'll show you that example here. Although a dictionary would be harder. It would kind of suck to create the dictionary by hand. I would probably programmatically make the dictionary. So yeah. So what he wanted to do instead of saying map, I don't want to make a dictionary. We'll call this map dictionary. He did something like this, where he had a 0, 0. It is colon, right?
Yes.
Yeah. And then 1 1, blah, 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 blah.
Your hands.
And then Z 35. And then what you could have just done here is you could have returned map dictionary at position char rep number. So you could have done it in 2 lines of code with a nasty dictionary you had to write by hand, which is fine. But heck, this is almost as tedious as writing the 36 if statements. But it's fine. I mean, it's a perfectly reasonable solution. Yeah, as long as you understand it. Yeah, so typically, and I answered this question for somebody else today as well. So typically what I'm looking for when I give you assignments, I want you to solve them in terms of what we've discussed in class. And it's okay. I mean, you know, it's not the end of the world. Even though you've learned some things in the book that we haven't necessarily discussed in class, it's not that those guys are bad solutions. It's that a lot of times I'm giving you problems in class that I purposely, almost always, as he pointed out, there's a better way to solve the problem. I'm kind of purposely throwing a puzzle to you that I want you to solve in terms of the tools that you have laying in front of you. You know, you went on the budget pleaser shopping spree at Home Depot, and the stuff you have in front of you are somewhat limiting, but that's how you're going to solve the problem. Does that make sense? Dictionaries are fine. This isn't like crazy out there, but for instance, there is a function that effectively does this chart int thing. Gives you, you know, it's a search function that lets you search and gives you the position within a string where the first character, where the character you're searching for is found. It's already written, but that then took away the joy of getting to write it yourself. Okay, but not just joy, the practice of being able to write this. That makes some sense? Okay, so this code right here, pretty much, well, not pretty much, this is identical to what we had in class last week, except for this function call, or last class, right? The only thing, this entire assignment, was that. Or the 36 if statements that some of you are too afraid to write.
Unreasonable, right?
With cut and paste, your copy and paste, it's not that bad. Once you build it up to, like, you know, 10 of them,
What if you make a mistake within the code?
don't make a mistake. Even then, it's worth most points. You know, you returned the wrong number for a Z or something like that. It's like, oh, he's doing what a human being might do, right? I mean, in your world, if I handed you a note card with a letter written on it, or, you know, a character written on it, 0 through 9, A through Z, and you look at it, you're just going to say, well, actually, you probably take you some time to think about the Z, right? Maybe Z would be easier because you know how many characters in the alphabet, but some letter in the middle, like R, you know, you have to kind of count through, do the whole alphabet thing and doing your fingers. But generally speaking, let's just keep it on a simple example of this. If I hand you a note card that has the character 7 on it, and I ask you what the integer equivalent of that is, you would pretty quickly respond to me and say, that's a 7. Right? Completely unaware that you did any sort of weird mapping or whatever. For all you know, you just memorized that character 7s are the same as the number 7 in terms of mapping them. You asked a question. What is this guy? Ah, it's a 7. The number you're looking for is a 7. If I give you something a little crazier, like here's an R, what number is that? Then you start counting the alphabet and you come up with the final answer, whatever it is. Probably 21. It's got to be higher than that. 31, 28, 29. All of those are correct. We're going to go with that. Write a program that solves it. All right, so this make sense?
Yeah.
All right. In fact, here. Print chart int 27. I might have said 27. Is that one of them I said? Let's assume yes.
Okay.
Remember, this is all being.
That's fine.
It's fine.
All right. Does this make sense? So, most of you, I would guess probably all of you, but most of you wrote more than just this for this assignment, right? You tried to do a bunch of crazy stuff. I saw some of the people were asking questions. You had loops inside of loops inside of loops and all sorts of things. Why is that? One initial thought is you probably dove into code before you should dive into code. How did we start today's class? We start today's class asking, what was the difficult part of this assignment? Converting values like A to 10. Solve individual little problems. Get little wins. So I have a widget that does this, and I have a widget that does this, and I have a widget that does this. That make sense? All right, so that is a reasonable solution to that problem. We put that up on Slack. Any questions about?
What's that new announcement that you have?
Well, I probably have a message from a student.
No, the one above what you're gonna post here.
Oh, yeah, we'll talk about that. What code snippet? All right, so as I put up on Slack, we will have our midterm next Friday in here. So right before spring break starts, you have a better chance of remembering that stuff before spring break than after spring break. Okay, we will review for it on Wednesday, right before the exam. So any questions that you have that you want to go over, let me know. The exam will cover primarily what we've dealt with in class. Super low risk of me asking something that was very minute or something like that in the book, or depending on what happens between now and Monday, let's say, for instance, if I don't introduce dictionaries in class, I won't ask about dictionaries on the exam. Okay, even though you've seen them in the book. We'll have plenty of practice with them. So I'm focusing on what we've done in class. Yeah.
Is it going to be like more towards the concept, or is it going to be like actually writing?
It'll be both. My exams, no matter what class you have with me, my exams have 10 questions on them.
Wait, really?
9 of them are unanswerable. My exams all have 10 questions on them. I actually write them all in a row, and then you can use the rest of that piece of paper for it or turn in your own paper with your name on it, because I don't want to print a bunch of stuff and use staplers, so I'm lazy. All right, so there are always 10 questions. The farther you get into the program, the higher percentage of the, in the computer science program, the higher percentage of those questions that will be actually coding. What I would expect on this exam is probably 7 of the questions to not be coding. And 1 or 2 questions will be, probably 2 questions will be you writing code. One of them might be kind of write a couple of lines that does something. Another one might be write a function that does something. And then there'll probably be me giving you code telling me what does that code do. That would be the other programming related one. Okay, the other things would be conceptual stuff. It would be possible for me to give you more questions where I give you code and say, what does this do? But you'll only have to write code for, I haven't written the test yet, but call it 2 questions. And probably only 1 question would be not a really difficult question, but what you might think of as being a fairly complex question. So if you come into this exam and you feel like, I suck at programming right now, I'm basically leaving that one blank, which is okay. Because remember, I have my policy where if you do better on the final exam than you do in the midterm, I'll replace your midterm exam grade with the final. Okay, so this exam is low pressure. If you get a 0 on it, you can still get an A in the class. All right, but if the worst you're going to lose on the exam with complete incompetence in programming is 30%. Okay, if like code is just gibberish to you. That make sense? All right, go ahead.
Can we use a calculator on the test?
Sure. Yeah, or you can use your phone, whatever, just don't Google stuff. You're only hurting yourself, I don't care. I get paid either way.
When is the hackathon again?
It's April.
I don't know.
It's April-ish.
April 13th. Is that Saturday?
Memorize
Yeah.
that.
It's on Slack. All right. So let's talk about our next homework assignment that our friend suggested.
I want to grab this.
Oh, this is going to be great.
I'm gonna grab the next show.
All right, homework. Let's say, because we already have a function called int. So if I pass like 123 to int, it will spit out 123. All right? For this assignment, you can't use int.
What?
Can't use that function for this assignment. So what you're actually doing for this assignment is you are write the int function. So you're going to write your own function. You can call it int. Well, actually, you probably don't want to call it int because that'll conflict with the other one. But you can call it my int or something like that. Write the int function that takes a string representation of a number as a parameter. I'm going to say of a base 10 number, so 0 through 9s only. Yeah, this isn't a, this isn't a conversion question. Well, it is sort of a conversion, but so write the int function that takes a string representation of a base 10 number as a parameter and returns the decimal equivalent. So, for example, if you took in 123, it should spit out 123. If you took in the string 456, it should spit out 456. Make sense? If you see the trick, don't say anything. All right, everybody understand what I'm asking you to do? You are writing your own version of the int function. Questions, comments, concerns, bribes? Go ahead.
So you can't use the int function, but you can create something similar to it.
You are creating the int function.
Okay.
I mean, that's the homework assignment, is write the int function. But you can't use it yourself.
Okay, got it.
All right? All right, I will see everybody on Friday.